The next thing we need to do then is to construct a copy of an angle. Now, constructing a copy of an angle means that we're going to be constructing a pair of congruent angles. We start with one angle, we construct an angle that is congruent to it. All right, here's how we begin. You need to have an angle. So, using your straight edge on your paper, let's make an angle. I'm going to make an acute angle because they don't tend to take up quite as much room. So use your straight edge. Something like that. And we'll call this angle AVC, or whatever you want to call it. And we are going to construct an angle that's congruent to this. All right, to do that, we begin by having a segment. So, construct a segment, use your straight edge. Nothing is free-handed. And now, and let's call this something. The book calls it point G here at this end. So I'll call it G. We get our compass. We move it to the vertex of our given angle. So move the point to point B. And we stretch out the pencil away. Doesn't really matter how far it is. So just stretch it out to some distance that you're comfortable with. Okay? Now, make an arc that goes through both sides of your angle. Notice that mine, I didn't hit either of those labeled points. So you don't have to hit either of those labeled points. The odds of you hitting both of them are really slim. Okay? So I need that arc. Now what I want to do is I want to take this arc and duplicate it down on point G. So do not change your compass settings. Move your compass to point G and make an arc. Make sure you go up at least as high above that ray that you have with an endpoint of G as you did for the angle. Now, what we've done so far is the distance from G to that arc is equal to the distance from B to that arc, correct? What we do next is we take our compass, let's put one point where the arc crosses one side of our angle and adjust it until the pencil is where the other, or where the arc crosses the other side of the angle. See how I've got mine? On the arc. On the arc. The points on the arc, the pencils on the arc, the points where the arc crosses one side of the angle, the pencils where the arc crosses the other side of the angle. So it's really important you get your point and your pencil both on the arc. Okay, you with me? Now, I move that without changing that new setting. I move the point down here to where the arc crosses one side of the new angle we're making. And I make an intersection there on the arc. All right, everybody's construction looks something like this. All right, now they told us to call this point H, and they said call the point where the arcs intersect here F. And do you see what's going to happen next? You kind of seeing what's going on? If we take a ray and we start at G and go through F, we've made a pair of congruent angles. Or the new angle, angle FGH, is a copy of the original angle, angle ABC. And you might look at mine and say, they're not the same size. No, you're right. The rays, the sides of the angles are not the same length. But remember what makes angles congruent? Having the same measure. Okay? So the degree measure of angle B and the degree measure of angle G are going to be the same. They're going to be equal to each other. Okay? So that's how we construct a copy of an angle. Or that's how we construct congruent angles. Everybody with me? You kind of see why it worked? Because what I did is I ensured that the distance from the arc to B and the arc to B was the same as the distance from the arc from F to G and H to G. So then when I measured how far along the arc that distance is and made it the same here, then I did, that's how come I got the angles opening up the same amount. I measured them to make sure they opened up the same amount. Okay? Do another one on your paper to make sure you can. The directions are on page 39 if you get stuck, or you can probably look back at what you did, but do one on your own. You can do this if you want. If you take your protractor and measure and see if they're pretty close. They should be within a few degrees of each other. You're not going to get perfection. Each of mine appears to be about 30 degrees. So I'm feeling pretty good about that. All right, any questions? Need more time? All right, you'll want to do some more of these, okay? Just doing a couple probably isn't enough for you to get good at it, so do some more of these. All right, before we do our next construction, which is going to be the construction of an angle bisector, we need to know what an angle bisector is. So, a ray that divides an angle into two congruent angles is called an angle bisector. In this figure, ray YW is the angle bisector of angle XYZ. Okay? Why? Because it divides angle XYZ into two congruent angles. It divides it into two equal halves. Remember, bisect means to cut into two equal halves. So angle XYZ gets cut into two equal halves. Or in other words, angle XYW is congruent to angle ZYW. Okay? So it cuts the angle. It's an angle bisector is a ray that cuts the angle into two congruent angles, or two equal halves, or two angles with the same measure. Okay? Now, just like we would add up lengths of segments sometimes to get the length of a larger segment, we can do the same thing with angles. We can add 80 plus 80 and decide, oh, that means the measure of angle XYZ must be 160. Eventually, we'll call that the angle addition postulate. Okay? And I don't remember if I mentioned this the other day, but when you put a little M in front of your angle symbol, that means measure of. So this means the actual angle, the physical angle, XYW. You put an M in front of it, and that means the measure of angle XYW, which will be a number. Okay? All right, let's see if we can bisect an angle. So these directions are on page 40 at the bottom, but I'll go through them with you and show you how to do it, see if I can make some sense. So if we're going to bisect an angle, probably not real surprising that we need to begin with an angle. So construct an angle on your paper, and again, I'm going to make it an acute angle just because they seem to take a little less room, seem to work out fairly nicely. So I'm going to start with this acute angle. I'm going to call it angle P. And I'm going to bisect angle P. So you use your straight edge and you constructed angle P. Okay? Now, get your compass and put the point of your compass on the vertex of this angle, so on point P. And stretch your compass out as far as you want to, a length you're comfortable with. Something you can use well that's not going to be difficult for you. And what I'm going to do, I've got the point of the compass on the vertex of the angle. I'm going to make an arc through both sides. Okay? Now, I'm going to then move the point of the compass to one of the points of intersection of the arc in one side. Maybe if I label it something, it'll be, well, let me move this out of the way. And I'll do what the book did. I'll label that R, that Q when I get the compass far enough out of the way. So R is the point where the arc intersects one side of the angle. Q is the point where the arc intersects the other side of the angle. Now put the point at R where the arc intersects one side of the angle, and I'm going to make the interior of our angle, but just make a big old arc, because I'm going to make another one that intersects it. So, you know, it actually doesn't really matter. Might as well. Okay? Since it usually does matter, you know, we'll just keep it the same length. So I made that arc from point R. Now I move my compass to point Q, where the arc intersected the other side of the angle, and I'm going to draw an arc that intersects the one I made from R. So I did that with the point at point Q. With me? All right. Use your straight edge then. Well, let's name that intersection of the blue arc. The book calls it P, so we will too. So then, at point T, use your straight edge and make ray PT. Start P, go through T, and we have constructed an angle bisector. Ray PT is the bisector of angle QPR. Now, that tells us things. And that's all you got to do. You're done with the construction. Now, let me make sure you understand what else it tells us. So we can now call ray PT an angle bisector. And mine just moved again. Why did it move again? All right, I can now call ray PT an angle bisector, which means then that angle QPT is congruent to angle RPT. You don't have to label that. I just need you to understand that's what it means. So if we knew that the measure of angle QPR was 70 to start with, we just made a pair of 35-degree angles. If we didn't know what it was to start with, but let's say now we knew that the measure of that one was 40, that means the measure of the other one's 40, and the measure of angle QPR is now 80. So we've got a pair of congruent angles out of this. Whenever you make an angle bisector, you've also made a pair of congruent angles. Okay? See if you can do that on your own. So on your own paper, construct an angle to start with, and then construct its bisector. All right, we've already worked the first 8 problems on page 41 together. Let's pick it up at number 9. Now, I do suggest you draw this figure on your paper, and you can draw it. You don't have to use your straight edge. You can if you want. Just draw this figure on your paper, etch it. You don't need to construct it. What you need to pay attention to is what it tells you in the direction. It says in the figure, ray KJ and ray KL are opposite rays. Now, since they're opposite rays, one of the conditions for opposite rays is that they're on the same line. So isn't that, in effect, telling you that that line, JL, that looks like a line, really is a line? They don't really have to tell us that. We're able to assume that if it looks like a line, it is a line. Then they tell us that ray KN bisects angle LKM. All right, so look at angle LKM. It's this one. That gets bisected by ray KN. Now, we know that a bisector divides an angle into 2 congruent angles, or it divides an angle into 2 equal halves. So we know that those 2 angles, and you use the little arcs, all right, when I put that arc there and then that arc there, that means those 2 angles are congruent, okay? Some books, and in fact, the ACT does not do that. To mark angles congruent, they will then put a little hash mark on their arcs. So you'll see it both ways, okay? All right, so that's going to be true for number 9 and for number 10. Now, for number 9, let's put on here the information specific to number 9. If the measure of angle LKM, so LKM, the larger one, and here's how I can indicate a larger angle with other angles that are inside of it in its interior, I can do that. And I'll make double arc just so I don't confuse it and think that somehow it's congruent to one of those small ones, okay? So that indicates that the angle measure I'm getting ready to put in here runs all the way from this ray to this ray, okay? So it's 7x minus 5. And the measure of angle NKM, now NKM would be this smaller angle, is x plus 1. So the measure of that one is x plus 1. And they want us to find the measure of angle LKM. Yeah, question? Instead of x plus 1, it says 3x plus 9. All right, 3x plus 9. Yeah, that'll happen a few other times in the book where the electronic copy that I have does not match the printed copy. Kind of frustrating. All right, so everybody's got 3x plus 9 in their book? Okay, good. All right, now, if those two angles I have marked in red are congruent to each other, if the measure of one of them is 3x plus 9, isn't the measure of the other one 3x plus 9? And can't I then work it this way? If I knew that the measure of each of those smaller angles is, say, 20, wouldn't I find the measure of the larger one by adding 20 plus 20? Well, I don't know that it's 20, but I know that it's 3x plus 9. So can't I say that 3x plus 9 plus 3x plus 9 equals the measure of angle LKM, the measure of the larger one? And what did they tell us is the measure of angle LKM? 7x minus 5. So, you following me on coming up with the equation? Because we're going to do tons of these before the year is over. Yes? All right, well, we're in business now. Simplify on the left. 3x plus 3x is 6x. 9 plus 9 is 18 equals 7x minus 5. How about we subtract 6x from both sides? When I subtract 6x from the left, I get 18 left over. When I subtract 6x from the right, I'll get an x minus 5. Now all I got to do is add 5 to both sides. And what does x equal? 23. And now that I have x, I can figure out the measure of angle LKM. The measure of angle LKM is given to us as 7x minus 5. That'll be 7 times 23 minus 5. What is 7 times 23? So I get 161 minus 5. So the measure of angle LKM is 156. Okay? Good for number 9? Let's do 10. So, I'm going to erase the angle measures they had given me. I'm going to leave those two angles marked congruent because they're still congruent. They just have different measures this time. So for number 10, the measure of angle NKL is 7x minus 9, so label that on your drawing. And the measure of angle JKM is 4x minus 3. Well, we haven't used that angle yet. 4x minus 3. Oh, different ones in the book. 7x minus 9 and x plus 3. Okay. All right, now, if those two angles are congruent, they have the same measure. So if one of them has a measure of 7x minus 9, so does the other one. And then here's where we need to know something that the book really doesn't tell us yet. And that's this. When they told us that ray KJ and ray KL are opposite rays, that pointed out to us that they're on the same line. Our definition that this book uses of an angle, if you remember, it was two non-collinear rays with the same endpoint. Okay? So by this book's definition, there is not an angle JKL. However, several books do not include the word non-collinear and just say two rays with the same endpoint, in which case angle JKL does exist. Okay? We want it to exist because we want it to be what's called a straight angle. And the measure of a straight angle is 180. Just like a right angle is always 90, the measure of a straight angle is always 180. So even though our book doesn't define angle that way, they still expect us to use that fact to solve problems. Okay? So, if it looks like a line, it's in effect a straight angle. And if it's a straight angle, its measure is 180. Since its measure is 180, this plus this plus this must equal 180. And that's how we get our equation. So, x plus 3 plus 7x minus 9 plus 7x minus 9 equals 180. When you add all the x terms on the left, what do you get? So we get 15x, and when you add the constants together, a negative 15 equals 180. So add 15 to both sides, and you get 15x equals 195. And you divide 195 by 15, and x equals what? 13. All right, now, what was the question? Because I've kind of forgotten it. It was to find the measure of angle JKN. Ooh, didn't really see that coming. JKN is this one. So I got to find the measure of that one. Well, they didn't tell us, but doesn't the measure of angle JKN have to be x plus 3 plus 7x minus 9? X plus 3 plus 7x minus 9. All right, so that would be, I'm going to simplify this before I substitute the 13 in. That would be 8x minus 6. Now, substitute the 13 in. So that becomes 8 times 13 minus 6. What is 8 times 13? So I get 104 minus 6. And what's 104 minus 6? So the measure of angle JKN is 98. All right, so you got to use your noggin on problems like this, don't you? Okay. All right, everybody still with me? Number 11. A miter cut is used to build picture frames with corners that meet at right angles. Jose miters the end of some wood for a picture frame at congruent angles. What is the degree measure of his cut? Explain and classify the angle. All right, so in other words, when you put the picture frame together, that's a right angle right here. And it says that he cuts it at congruent angles. So if you take a 90-degree angle and cut it into two congruent angles, what's the measure of it, of each angle? 45. So that's a 45-degree cut, and we're supposed to explain since a right angle is divided into two congruent angles. And we called it a right angle, so that was our classifying as well. So we explained and we classified at the same time. Then B says, that was A, B says, what does the joint represent in relation to the angle formed by the two pieces? Here's the joint. What's that? That's the angle bisection. Any questions? Okay. Those are the 3 learning targets we've covered. We defined angle, we constructed a copy of an angle, we constructed an angle bisector, and there's your assignment. Page 41, 1 through 11, which you should have 13 through 23 odd, 37 through 42, 54 through 57. Make as many constructions of a copy of an angle as you need to get good at it. Make as many constructions of an angle bisector as you need to get good at it.